Now, we are going to extend the regression model to have another regressor. So previously, we considered men and women. Now, consider a dummy variable for age. So simply, I will consider A as the individuals who are 40 years or older. And B is the group who are younger than 40 years old. So 39 or younger. So exactly the same structure, men and women. So you are either 40 or 40 plus or 39 minus. You belong, like anyone belongs to one of those two groups. So always A plus B is always 1. Then in this case, like also it is helpful to think about the groups, underlying groups in your data. And in this case, you have to think about 4 groups because you have two binary variables. So you have 2 by 2 groups. So there are 4. Simply male 40 plus, and male 39 minus, female 40 plus, female 39 minus. I'm going to simplify 40 years as 40, 39 years old as 30s. So in their 30s or 40s. So there are 4 groups, and you have, from the data, you can calculate 4 group averages. So this is the starting point, and let's see what's the difference. I'll give you several wrong models. These models do not work. So first multicollinearity case is when you include everything. So you include intercept and man, women, 40 years old, 30 years old. You included everything, which does not work. So then you know that it does not work, but you have to tell that there are 2 multicollinearities at the same time. First multicollinearity is coming from like 1 equals to m plus f. So m and f themselves are multicollinear. So that is first multicollinearity. And second multicollinearity, another multicollinearity is coming from A and B. Same structure, but they are different multicollinearities. So in this case, the problem can be seen directly from the equation, considering the number of groups. So you have 4 groups, but the equation has 5. Equation has 5 parameters, so you cannot handle all those parameters, 5 parameters using 4 groups in your data. So it's not working. And then the problem here is, so another wrong model is when you drop f. So okay, you may think that okay, there is a multicollinearity problem, so we need to drop 1. So you drop f. Still, it's wrong. It's not working because A and B, the multicollinearity in A and B still remains. This problem still remains. So it is coming from this. So what you need to tell from here is, as I said, you have 2 multicollinearity. So I write it this way. And so they are separate to different multicollinearities, but dropping f only fixes this problem. So as long as you include A and B at the same time, the other multicollinearity does not go away. It's still there. So you still have a multicollinearity. Another thing you need to realize here is that in this case, it looks fine because there are 4 parameters, alpha, beta, gamma 1, gamma 2. But so 4 parameters, 4 groups. They look okay, but actually not. So those 4 parameters are not correctly capturing the groups. So I will show you what's the problem in like later, and the correct model later. And first, clearly you have to tell that multicollinearity remains here. And same problem here, M and F remains here. And same problem remains here. M plus F equals A plus B. So it does not work. So the second, third, fourth models have 4 parameters, but they cannot handle these 4 groups. That's easy to tell. It is easy to see where is the multicollinearity and why they are a problem. Okay, so now let's think about the correct model. This is the correct one. You have to think about interaction term. So multiplication of two dummy variables. It is required because we are looking at 2 by 2 case. So you have to have a cross term. You have to, 2 dummy variables have to cross each other, and that is provided by this interaction term. And then now think about the group-wise averages. Female 40 years old will have alpha, beta, gamma, delta. So everything is 1. Female 1, 40 years old 1, 1, 1. So everything is 1. All the parameters survive. And second group, man 40 years old. Man, so F is 0, A is 1, 0, 1, so the interaction is also 0. So interaction term takes 1 only when F equals to 1 and A equals to 1 at the same time. So these 3 groups, only the first group has the interaction term in here. Otherwise, the other 3 groups do not have this part because one of them is 0. So 0 times something is always 0. So anyhow, it is easy to tell, easy to see how you obtain the group average, alpha plus beta and alpha. And easier, like another easier way to understand is the table. So we have these averages in each group, and this table helps to see what the parameters imply. So next, I will interpret. First, let's think about alpha. Alpha is here, so it's clear. Alpha is the average wage for man 30 years old. 30 years old, so alpha is the reference point. We call this reference group. So that's the starting point. And from here, from this group, we will calculate the difference. The other groups are calculated as the difference from this reference group. So reference group is the reference. And beta is the difference between these two. Difference between men and women among 39 minus years old. So I will call this the gender gap. So female premium, maybe this is a better one here, is female premium, because when I say premium, it shows what you subtract from what. So female premium is the difference of female minus male. So I will call this way, female premium. So the premium can be negative. So it's value neutral. I'm not saying female is superior or inferior. It's not. It's neutral, just statistical term. So beta is the female premium among 30 years old. And in the same way, gamma is the difference between this and this, which is the difference between 40 years old and 30 years old within man. So it is the age premium among men, right? So you have to include this condition. So the difference among women is not gamma. So that's one thing you have to be careful when you interpret this model. And then finally, so far it's not that difficult, but what the difficulty is in delta. How would you interpret delta. So there are two different ways. First, think about the difference between these two guys. Among the younger people, younger generation, the female premium is beta. But in the older generation, the female premium is beta plus delta, right? Difference between these two guys is beta plus delta. So therefore, delta captures the difference in female premium across generations, right? It is difference in differences. So the first step differences is across gender. Like female premium is one difference, first step difference, and then compare, and then you obtain female premiums from younger generation and older generations. Compare these two female premiums, and then you get another difference. That is delta. This is one possible way to interpret delta. Alternatively, you may consider this difference first. So the age premium among men is gamma plus delta. Gamma, say. So gamma is the age premium in male. And for women, the age premium becomes gamma plus delta. This is the age premium if you compare these two. If you compare these two, gamma plus delta is the age premium, then you can say that delta is the difference in age premium across gender, right? So it is also difference in differences. Right? You first calculate the difference across ages and then compare the differences, two differences across gender. So then you have those interpretations. So it looks confusing. Yes, it's confusing, but when you make the table, it will be much easier. So think about this. If you are confused, try to interpret what happened here. And I'll show you another multicollinear model. Another multicollinear model is this. So you are including interaction variables, but there are multicollinearity in the interaction variables. So because a plus b is always 1, fa plus fb is always f. So including these three variables do not provide a working good model. So it is a big problem. It's not working. And another alternative model, then so if you don't want to have a reference group, but you'd like to have one parameter for each group average, then you have to consider this. Simply, you can think it as like you are defining the regressors for each group. So this takes 1 for this group, and this takes 1 only for this group. So there are 4 groups. So you can think about the group as another variable that can take 4 different values. Then you have one-to-one between the parameter and the groups. So it is possible. And there are many other models, but there are too many models, so I cannot list them all here. So think about what you'd like to use in different situations. So also it is your choice depending on your research question and how you parameterize the differences or the group averages, and what's the easier way to explain to your audience. So that should be your choice. So it will be nice. So I can tell you. So for example, like maybe something came to my mind. Another model can be something like alpha without intercept. You can think about this. in this case, alpha captures the group average for younger women, and gamma captures group average for younger men, and beta and delta captures the age premium for men and women. So in that case, this may be convenient if you're interested in the gender specific age premiums. So you can write more examples, but there are too many, so I'm not going to explain all of them. Okay, see you in the next one. I will there are a little more things to explain, so